Hey guys, so today we're going to be looking at higher order derivatives and then combining that with our knowledge of implicit differentiation. So basically what we're starting off with is a differentiable function. So if you have a function f, then you can take its derivative, right? So we have f prime. This f prime is also going to be a function. So technically you can take the derivative of this piece as well. It may have a derivative of its own. And so when you take the derivative of the derivative, you get f double prime. This new function is called the second derivative of f because it is, in fact, the derivative of the derivative. Using some Leibniz notation, we typically write the second derivative, the second derivative of our function as this. So you could write it as y double prime. You could write it as the derivative with respect to x of dy dx, which would be the second derivative, this one. So regardless of whether you see f double prime, y double prime, or d squared y dx squared, those all mean the second derivative, okay? You could also find the derivative, so f triple prime. This would be similar to if you had y triple prime, or it could be f triple prime of x, or you could be taking the derivative of your second derivative with respect to x, so you'd end up with the third derivative notation like this. And the process can be continued, so on and so forth. So your fourth derivative would have 4 apostrophes, but we usually start after 3, start writing them as like f to the fourth, f to the fifth. And so in general, you would say f to the n like that, and that would be the nth derivative. So you could do like the 100th derivative, or the 1200th derivative, or the 10 billionth derivative. So in general, if you have a function y equals f of x, we would write y to the n, but we use, so that it doesn't look like an exponent, you use those parentheses, and then f n of x, or it could be d dx of d to the n. Oh, I guess it would just be this part already. dn y right? So any of those would imply more, like you could do your second derivative, third derivative, and nth derivative, all using any of those notation pieces. So let's do some examples. So in this example, they want us to find our second derivative. So I'm going to find y prime first. And you can either write it using y prime, or most often we see it written as dy dx, especially when we start looking at some implicit differentiation pieces here. So it's up to you. So my first derivative of this would be negative 2x. And then to find my second derivative, I just do the derivative of that piece. Oh, I might have to use y primes just because I'm going to run out of space. So my second derivative would be negative 2. I'm just taking the derivative of the derivative. This one, they give me y, so then y prime would be negative 4. Y double prime would be 0, because the derivative of a constant is 0. And then look at this, y triple prime would also be 0. With polynomial functions, you'll find that if you take more and more derivatives, eventually you'll narrow everything down to 0, because your exponent on your x will just keep decreasing until your x's are gone, and then you just have constants, and the derivative of constants are just 0. So like if we look at this one, let's find the fourth derivative of this. So y prime would be negative 20x to the third. Y double prime, second derivative, would be negative 60x to the second. Third derivative would be negative 120x. And and then our fourth derivative would be just negative 120. So you see how the x's just kept whittling down until you ended up with no x's, and now our derivatives from here on out will all be 0. If we look at these next ones, all right, the third derivative, so we would get, y prime would be 15x to the fourth minus 2. Y double prime would be, what's that, 60x to the third. And y triple prime would be 180x squared. You just keep working your way down. It's nice practice with derivatives. Okay, third derivative here. So y prime would be negative 6x squared. Now careful here, you got a negative exponent, so this would be positive 12x to the negative 4. Your second derivative would be negative 12x. This would be negative 48x to the negative 5th. Lovely. Your third derivative would be negative 12, oh geez, plus 160. 5 times 40, 1, 8, 20, 5 times 8, 40, yep, okay. And then to the negative 6. Lovely. All right, and then this one, we just gotta be careful. It might be helpful to rewrite this piece first. This is really x to the 2/5, right? So when I do y prime, I'll get negative 2x plus 4/5 x to the negative, let's see, 2/5 minus 5/5 would be negative 3/5. Y double prime would be at negative 2 minus 12 25ths x to the negative 8/5. Yep. And then y triple prime would be, that would just be 0. Derivative of negative 2 would just be 0. So then this would be, let's see if we can do this. 8 times 12 would be 96 over 25 times 5 is 125x to the negative 13/5. Nice. So that's basically the basis of, or the foundation of higher derivatives, is just knowing that it means derivatives of other derivatives. And we'll get a little bit more into the context that these have when we start our next unit, looking at specifically velocity, position, and acceleration, and how it applies to physics, because that's the most easily understood situation. And so then now we're going to look at how implicit differentiation plays into this. So basically we can do the same thing with functions that we have to differentiate implicitly. So this one wants us to find our second derivative using implicit differentiation. The problem with implicit differentiation is there's one more little step you have to do. So I'm going to show you how to do that. First, we're just going to find the first derivative, right? We can't find the second derivative without finding the first. So y prime, or this is also another way of saying I want the, second derivative, right? So I'm going to start with this piece. So derivative of x squared is 2x. Derivative of 4y squared is 8y dy dx, because every time you take the derivative of 4y, or a function that has y in it, you have to tack on a dy dx. Derivative of 1 is 0. And so then we'll get, let's see, got my 8y dy dx equals negative 2x. Divided by 8y on both sides, so dy dx equals negative, let's see, negative 2 divided by 8 would be negative 1/4. So that is my first derivative. And so then now, this is my first step, I'm going to have to go ahead and I'm going to find my second derivative. So I'm going to take the derivative of this piece. Now on the left-hand side, when I do that, when you take the derivative of dy dx, you get the notation that we need, right? On the right-hand side, we'll have to use quotient rule. So low d high minus high d low, derivative of 4y would be 4 dy dx all over low squared. Now, this is the piece that you have to watch out for. So this part right here, whoops, not that whole part. We still need this to be squared, thank you very much. This piece right here, dy dx, we actually know. So you're going to go ahead and you're going to substitute this in for dy dx, so that way we can simplify as much as possible. Oh, here. So this would be negative 4y plus 4x times negative x over 4y. Right, because I just did the negative times the negative x times 4. So I got 4x, and then I multiplied it by dy dx. And then that's all over 4y squared. All right, let's simplify a little bit more for this piece. So let's see. We can do this. this. Let's pull this up, my 4y squared. Here, I'll show you what we're going to do here. Instead of dividing by 4y squared, you're going to take your whole thing and you're going to multiply it by 1 over 4y squared like that. Oh, I guess we could write it as 16y squared like that. And so then now we're just going to multiply everything through and simplify out my y's. So I'll end up with, let's see, negative 4y over 16y squared plus, well, actually minus, because negative x times 4x would give me negative 4x squared over, what's that, 64y cubed, correct? Awesome, and then we can simplify it one step further, and that could be to reduce as much as possible. So 4 over 16 reduces to 1 over 4, got rid of one of my y's there, so we'll end up with our second derivative. So this is most likely what it would look like as far as a multiple choice question would go, would be negative 1 over 4y minus x squared over 16y cubed. Or they might have common denominators and combine those, but really this is us simplifying as much as possible. So it's still the same concept, right? You have your first derivative, you're finding your second derivative, and then you are, the only thing you have to do separately is when you find your second derivative of implicit differentiation, there will be some other dy dx's in there, so you need to make sure to replace them with what they're equivalent to according to our first derivative. All right, let's try one more of these before my video timer runs out. So find your second derivative in terms of x and y for this function, or excuse me, this equation. So the first thing we're going to do is find our first derivative. So 1, oops, derivative of 1 is not 1, it's 0, and then minus. Here we have a little bit of product rule going on, so I'm just going to off to the side do that. We got x, we got y, we got 1, we got 1 dy dx. Right? Take the derivative, crisscross applesauce. So then we'll have negative x dy dx plus y equals derivative of x is 1, derivative of negative y is negative dy dx. Go ahead and distribute that negative. So then we'll have negative x dy dx minus y equals 1 minus dy dx. Get all my dy dx's on one side and then pull out my GCF of dy dx. So let's see if we can do that all in one step. Subtract that over, or excuse me, add that over, so it'd be negative x plus 1. And then on this side, we move that y over, so it'd be 1 plus y. Beautiful, and divide on both sides. So then we get that our, I'm going to run out of space. So it'd be 1 plus y divided by negative x plus 1. Beautiful. So that's our first derivative. And then we're going to go ahead and find our second derivative. And this one we're not going to simplify at all because it doesn't tell us to. And we'll pretend it's an f or q. All right, so our second derivative would be low d high. Derivative of 1, 0. Derivative of y is just dy dx. Sorry, product rule, you gotta go. Minus high d low all over low squared. The only thing is that they want to make sure that you find it in terms of x and y, so your last step is actually going to be to replace your dy dx with what it's equal to. So we did actually get, and again, I'm not going to simplify it all because it doesn't tell me to, and I don't want to mess it up. But it'd be good practice as well, so up to you. Beautiful. I mean, it's not, but it is. Awesome. So let's go ahead and pause here, and then if you want to take a break and move on to the next video, you absolutely can.